Good afternoon, Liberty North AP and dual credit psychology. This is the last live stream of your virtual Wednesday on October 7th. So hopefully this is the best one. If not, I've got periods in there, which is pretty good. So today we're going to be covering learning targets number 7 and number 8, all right, from Unit 2. So Unit 2 AP learning targets number 7, number 8. These are going to be on pages 53 to 63 in your textbook. So again, remember, we're going straight down the learning targets, which doesn't always match sequentially with your textbook. So this one actually does a lot of jumping around. So just 53 to 63, okay? All right, and this is number 7, and this is number 8, okay? And we'll go down them, and I'll read them to you here in a minute. Before we do that, though, I'm going to just show you the final results of our Mozart experiment study. So A days, again, got Mozart and then did the memory test. B days got Beethoven, did the memory test. So B days was kind of our placebo control group, if you will, our fake Mozart. And as if you look closely, you'll probably see that there is an effect both days. There was a Mozart and a Beethoven effect. Beethoven effect is a little bit greater. Okay, so we can definitely kind of verify with our replication, kind of verified the study that we saw from the UK, which said that Mozart music and rock music, there isn't much of a difference. And there isn't much of a difference between those two in silence as well. Okay. And then over here, we listed some confounding variables that we found in the study. So variables that impacted the results probably that we weren't planning on. So Skittles, doing our Skittle lab and having a sugar rush, okay, impacted it. The same picture, I made a mistake on memory trial 1 and 3. They had the same picture. Time of day, which you can definitely see, I think, here. So these results seem to verify what neuroscience is saying, and that somewhere between 2nd and 4th hour is your cognitive peak. All right, and then in the afternoon, you kind of have cognitive decline. And then, of course, the experience effect. Okay, so in both the original Mozart study, our study, and the one that we watched online, you know, you're doing the same tests multiple times. So, of course, there's going to be a practice effect, an experience effect there in which you're just naturally going to get better. So your score should naturally go up anyway. But we want to make sure that it's from the Mozart music and not from anything else. Okay. All right. So here's learning targets 7 and 8 from Unit 2. And if each unit you want to start taking a picture of these, that way you can kind of have it on your laptop or your cell phone. Might be a good idea since they keep disappearing, and then the janitor's cleaning the room. You know, I think they're just tossing them. Okay. All right. So number 7 is apply basic descriptive statistical concepts, including interpreting and constructing graphs, calculating simple descriptive statistics. And number 8 is distinguish the purposes of descriptive and inferential statistics. Okay. So we're going to do number 7 first, which is apply basic statistical analysis, okay? So we're going to start with these two right here, okay? The first thing in statistical analysis that we need is we need a thing called statistical literacy, okay? Which means that you can read, quantify, understand, and calculate statistics, okay? Statistics play a huge role in research, and they help us understand and communicate the true, clear picture of the results. Okay. So not only do they help us understand the results, but then they help us understand what we can do with the results. Right. So at both levels, you have statistical analysis that take place. Now, in any science, stats are important because they help just portray the results in a way, a chart or a graph, you know, a data analysis in a way that we can understand it. And then they also evaluate the research statistically. So they give us ideas on validity and reliability of the research. Okay. So what we need is we need people to learn how to read statistics. Okay. Especially in our culture and our society today. You know, I think I've read several articles that have said from several different publications saying that we are suffering from a lack of, or we're suffering from statistical illiteracy. Okay. So we, and the fact that we are really not thinking critically, we don't think scientifically naturally anymore. And that's why if, you know, somebody comes out and just says, you know, a recent study found blank, you know, people are just taking that for face value, because if they look at the study, they can't understand the statistics and they don't know what they're saying, you know. And hopefully, again, as we have repeated over and over in here, thinking critically and scientifically, the first time you hear a study, you need to ask some questions. Number one is, has it been replicated? Were the results reproduced? Okay. Who was the study on, or who were the subjects in the study? Because those are the only people that it could apply to, right? And then, what does the statistical analysis say? Let me look at the stats of the results, okay? So, you start really thinking critically, and, just when one study can never stands alone. So we shouldn't be generalizing results. So again, generalization, overconfidence, and bias are the three main enemies to scientific literacy and statistical literacy, okay? All right. Now, the book wants you to understand three basic type of statistical analysis, okay, still in number 7, right? And one of these is going to be a blast back to elementary school: mean, median, mode, and range, okay? But these are all measures of variance. So in research, we want little variance. We want small variance. We want all our results clustered around each other, okay? We don't like big dispersion or big variance in our data, our numbers, our results, or in anything, because that indicates something probably went wrong. It also indicates that possibly reliability and validity aren't going to be high like we want, okay, or like we would prefer. So again, you have the range, which is the highest, the difference between the highest score and the lowest score, okay? So again, if we don't like variance, we want that number to be small. Standard deviation, which is on average, how much do the scores differ from the mean, okay? And we want that number to be small, because if standard deviation is big, that means that the average scores are dispersed, right? And they're farther away from the mean. And then our normal distribution, okay, or what we call our bell curve. And then I want my stats or my data points evenly distributed with the mean right there, the average score right there in the middle, okay? Now the book walks you through a great example, and it's about a test. A professor gives the same test to two different classes, class 1 and class 2. Both classes, after the test is over, average 85%. So at face value, at the descriptive data level, okay, it looks like everything went well. It looks like the unit was taught well, the kids learned it. They scored 85% as an average for both classes, so it looks like it's reliable, okay? And then it also, gives hints that its validity is good, okay? Now, that's at the descriptive level. Now, if we look at the inferential level, okay, we're going to run our range, our standard deviation, our normal distribution test. Class 1, there's obviously a problem. Even though the average is 85%, the range is 50 points. So it's anywhere from 100 to 50. So they have really high scores and really low scores, okay? Now, they still average to 85, but there's a huge dispersion there. Not only that, the standard deviation is almost 15 points. So that means that on average, those scores are 15 points away from the mean, okay? Further indicating that there's more dispersion, okay, and variation in the results. And if we put them in our normal distribution, our bell curve, you're going to see that we do not have a bell curve. That curve is going to be flat and elongated because we have so much variance and so much dispersion in our results. Okay, so something happened with test 1. And we would need to, figure that out. Maybe I taught the information differently to each classes. Maybe they had different essay questions. There was a fire drill, or, there was something that impacted those results, because we can't take them at face value that they averaged 85% because there's too much variation, okay? Class 2, however, we can be pretty confident that the test was reliable and valid because their range is very small, okay? All of the numbers, the difference between the highest score and the lowest score is pretty small. And not only that, the standard deviation is less than 4. So all those scores are either plus or minus 4 from the mean score of 85, okay? So we have a very small amount of dispersion and variation there. And when we plot that on our normal distribution bell curve, we get a nice big bell curve with 85 right there in the middle, the mean score. And then it turns into this bell out kind of equally on both sides, okay? So it kind of mirrors each other on both sides. So again, at face value, hey, 85%, both classes, that's good. And even as a teacher, I'd be like, oh, that's good. But if we look at it closer, there's an issue with class 1 that would need to be looked at, okay? So that leads us into number 8, which is, what is the difference between descriptive and inferential statistics, okay? Descriptive statistics help me organize and summarize my results. They kind of help me paint that clear picture of what actually happened, okay? So, but those are pretty basic. So that could just simply be both classes averaged 85%. Both classes had 25 students take the test, that type of thing. The chart that we have over the Mozart effect, that's descriptive data, okay, statistics. I have just basically given you stats in a table that helps you really quickly look and see the results and understand them, okay? That's what descriptive statistics do. They just help me summarize the results, okay? Now, inferential statistics are at another level. And then those are the statistics that kind of measure, okay, well, what is the validity and reliability of what I've just found? And what can I do with that? Where can it be applied, or can it be applied, okay? So, so you have the kind of just organize and communicate level of the results, and then you have the layer of inferential statistics would help us analyze the stats and the results that we found, and what can we do with them, okay? Now, the best example of an inferential stat, which the book highlights, this is a vocab term, is what we call statistical significance, right? So in any research, we at the end of the day, we do a data analysis, which is an inferential statistic, which actually gives us a rating on the statistical significance of our study. Now, significance does not mean that it's important, or the results are important or impactful. What it means is, were they impacted by chance or something else, like a confounding variable, okay, and not really the independent variable or what we manipulated. So if a study is statistically significant, that means that the results were not impacted by chance, confounding variables, or something else, okay? We know that it actually was the effect that we were studying for that was actually measured, okay? If a study does not have statistical significance, that means that chance or something influenced the results, okay? All right, so if we go back over, the original Mozart study done in 1993, which was referenced in the study that we watched from the UK, all right, had a Mozart group like we have, and it had a fake or sham group, classical music like we had Beethoven, and then they had a silence group, okay? Now, all groups went up on the spatial reasoning task, okay? But the Mozart had the biggest increase, all right, in the original study. Now, after they did the study, though, and then when they considered all the confounding variables like practice effect, college students, and so on and so forth, they realized, though, that the results were not so much because of the Mozart music, but they were because of chance and the practice effect, okay? Which shows you that statistical significance was low for this study, which is what was rated in 1993 after the original study, okay? It was deemed to not be statistically significant, meaning that it wasn't the Mozart music that caused the effect. It was something else. It was chance. It was the practice effect. You know, something else besides just the type of music made the effect, okay? So statistical significance means that my results are not impacted by chance or confounding variables, okay? All right, this is on page 60, okay? All right, and then just 3 other things that we look for in stats and in results, and these apply to our external validity and internal validity that you're gonna do on your journal critique, okay? So representative samples are better than biased samples, okay? Which again, when we did our Skittle lab yesterday and Monday, that's why we value random assignment and random selection, because that takes the bias out of it and makes it random, okay? We want less variable results, okay? That gets back up to here, measure the variance. So we want our variance, we want our dispersion of our results to be small, to be all clustered and packed around each other, okay? Because that promotes validity and reliability. And then we want more cases rather than fewer cases, okay? Now, my representative sample is a part of external validity. My more cases is a part of external validity, and my variance is a part of internal validity, okay? When we study, was the research done well? Did it have integrity? And then the more people I can apply my results to, the higher my external validity is, okay? So obviously, if I have a representative sample, if I had all 5 colors of Skittles, that's better, okay, than missing a color of the Skittles when we did our lab. And then when I have more total Skittles or subjects, the more representative it is, okay? Which again, you know, we get there by replication, okay, and utilizing random assignment, random selection, operational definitions, okay? That's how we get there, all right? So again, we did the Skittles lab. I had 12 classes, and in each class there were 7 to 8 trials, right? Out of all of those, only 3 had a representative sample by themselves, okay? Meaning that they pulled out all 5 colors of the Skittles and they had them in proportion. What we had to rely on then is everybody else's individual trial. When we accumulated all those together, we had dozens of trials, in which we had a representative sample and we had a lot more cases, okay, which is better, which increases external validity. And that would be the replication process there, okay? And then when we do our inferential and descriptive stats, we want to make sure that we don't have variance, okay? All right, so, you know, it's going to be important for you to kind of read through these pages, especially as we get closer to our journal critique assignment, which we'll start and go over after this unit. Because you're going to have to get a psychological research journal and you're going to have to read it and understand what happened, and you're going to have to deal with some stats. Now, I'm going to help you. If you get confused, then you can just come in and we can go over them together. But, you know, I think that's important for us to kind of start changing the tide in our society a little bit to where we get back to more critical thinking and scientific thinking, you know, that we become statistically and research literate so we can learn to analyze and look at research and data from a scientific view and not just something to be used by the media, you know, to kind of sell a story or something along those lines. Okay. All right. So that's number 7 and number 8. Okay. All right. Any questions? Any questions? You can just throw them in the chat real quick. Okay, I'll take a picture of this and send it out on, actually it's already out. I already sent it out on Twitter this morning, so you'll have it. It's also the thumbnail of the video. Okay, all right, looks like we're good. So enjoy your virtual Wednesday and have a good day. We'll see you Thursday and I will be here on Friday. Okay, bye.